Right, so let's look at how to solve this example. Y equals the cotangent of 9x plus pi over 4. So cotangent, let's see. Let's see if I can write on here. The tangent goes from negative pi over 2 to pi over 2, and it sweeps up. I always think of it like a fancy T, like if I was a really good writer. Okay, cotangent goes the opposite direction. Oops, I gotta move my face. Okay, oh, could be smaller. So cotangent is going the opposite direction. And remember that tangent has asymptotes at negative pi over 2 and pi over 2 because tangent is y over x. And on the unit circle, x values are 0 there at negative pi over 2 and pi over 2. Okay, and then cotangent is the inverse of that. It's the reciprocal, not inverse, but the reciprocal. So it would be when y is 0, which happens at 0 and at pi. Okay, so and cotangent doesn't look like a T, it goes down. Okay, and its midpoint is there at pi over 2. So it's kind of broken down. You look at the midpoint between the asymptotes, and then you do the midpoint of those intervals to get your key points. So here the key point would be pi over 4 and 1, and the next one would be at 3 pi over 4 and negative 1. Okay, so that's kind of their parent cotangent parent graph. All right, now in this example, it's going to be affected by the 9 coefficient of x and then the plus pi over 4, that constant. So the easiest way that we have to come up with a new graph is let's just figure out where our new asymptotes are, and then we'll find the midpoint and then the midpoint of the intervals to get our key points. Okay, here we go. The example on my lab has you factor out the 9, which is great because then we see the phase shift and we see the period. I don't personally feel like we have to. I just know, okay, period of cotangent and tangent, both of those have a normal period of pi. So the new period, we would divide by that coefficient of x. Okay, so our period is pi over 9. Okay, now our original asymptotes were at 0 because it's cotangent and at pi because it's cotangent. Okay, so to find our new ones, what we do is we just take whatever is happening there inside cotangent. So it's 9x plus pi over 4. 9x plus pi over 4, and we just set that to what it used to be, those original asymptotes. Okay, and solving this, subtracting pi over 4 from both sides, dividing by 9, you would get x is equal to negative pi. Oops, I don't need that, sorry. Negative pi over, what is that, 36? Multiply both sides by 1/9. Okay, so here's my new asymptote. Is negative pi over 36. Okay, that is excellent start to this very long problem. Okay, down to the next one, we're going to subtract pi over 4 from both sides. 9x, what is that? Get a common denominator. So that would be 4 pi over 4 minus pi over 4. So that would be 3 pi over 4. And then solve for x here. Let's see, we get, let's see, my 3 goes in here. So it'd be pi over 12. Pi over 12. Okay, excellent. So I now have my asymptotes. So one's at negative pi over 36. And the other one is at pi over 12. Okay, and now my goal is to figure out the midpoint and then the midpoints of my two intervals to get my key points. Okay, so the midpoint of the asymptotes, let me just label those asymptotes. Let's see, this was at negative pi over 36, and this one was at pi over 12. Okay, so the midpoint, just add them up and divide in half to get my midpoint there. So negative pi over 36 plus pi over 12. Add them up and divide in half, or just multiply by a half. Let's see. Okay, so it would be, let's see, this would have to get a common denominator. So I would have negative pi over 36 plus 3 pi over 36. That gives me 2 pi over 36, but I'm finding the midpoint. So I'm, splitting that in half. So that would end up, my 2's cancel. So I've got my midpoint there is at pi over 36. So that would be this original point right here, pi over 2, 0. That's the midpoint between the asymptotes, and the output there is 0. Okay, so my new key point is going to be, there's the midpoint at pi over 36. Okay, and that's going to be my x-intercept. And now the other two key points, I only need 2 more for tangent or cotangent, is just going to be this one here, A, and this one here, B, where the output of A is 1, the y value, and the output of B is -1. Let's see. Halfway between negative pi over 36 and pi over 36 is 0. So there's my next point at 0, 1. And now I need to do this point here. Okay, these are the midpoints of the intervals. Okay, so I just did negative pi over 36 and pi over 36, and the midpoint there is at 0. And then my next one is the midpoint between pi over 36 and pi over 12. And to find the midpoint, we just add them up and divide in half. Add them up and divide in half. So let's see, pi over 36 plus pi over 12, just get a common denominator. So I would have 4 pi over 36, but that is 9. When I simplify, my 4 goes into 36 9 times, so that would be, oh my goodness, pi over 9 times a half, so it would be pi over 18. This right here is pi over 18, and so my key point would be at x value of pi over 18 and y value of -1. And now I can draw my graph of cotangent. Okay, but the thing that makes this hard, and I had to really scratch my head and look at this for quite a while, is that on MyLab, the choice doesn't have the asymptotes labeled actually, which is really confusing. What it does is it, I don't know why, but it goes to another, like it labels these outer points. So if I'm counting by, oh, I just don't even know why it does this. Let me just show you. Let me show you the option that it gives. Sorry, my writing is on here, but we can scoot this hopefully. Let's see. Oh. Here, I'll just erase this stuff. taking me a while. Okay, just doing my erasing, just peacefully going along. Okay, so here, let's go through this. We did all this. We did the midpoint of the mid intervals, got our key points. Okay, so do you see how this number right here is not actually the name of the asymptote? Asymptote is right here. This is negative pi over 36, but this is an extra interval across. This is pi over 12, but then if we add there, I don't know why they do this. They split the interval even up even further. So they even like found, did they, yeah, so this is pi over 9. Right, they split that in half, even another, so they went to pi over 9. So it is confusing because of the way that they've labeled these graphs. But look at the shape, and if you're doing all this work on your own paper on a test, you know, I can tell that you understand what you're doing. Okay, so I'm sorry the way that they label it. I wish that they had labeled the asymptotes more clearly. It would make it a lot easier. But that's kind of the big picture on how to do those. Let's see.